On a compass, the position is called the bearing, or it's sometimes called the heading. And what we do is we take the position. This is used for boats and planes and anything that is flying and it's not limited to roads or tracks or anything. You need to turn that into a triangle. So that's what I'm going to teach you how to do, is to take a compass bearing or compass heading and turn it into a triangle. So we're going to start the example is going to be to create triangles out of bearings. Typically, the way I do that is I draw a grid, and then I also put part of a compass like right on top of my grid, and I know that that's north, east, south, and west. So it's like you're superimposing your compass right on top of your grid. So example A we're going to start with has a compass bearing of 38 degrees. 38 degrees, so from the compass that we knew, okay, we can switch back and quick look at of 38 degrees. So that's about like right there. And compass measurements always start from the y-axis, which is the one that goes north. So 38 degrees, let me zoom in on this a minute for you. 38 degrees is measuring right here. That's 38 degrees. So from the north line, which is the y-axis, and then out towards the arrow that indicates 38 degrees. Now we want to turn that into a triangle. From our lesson before, we know that bow tie triangles always have to touch the x-axis. And so the triangle that we're going to create is going to use the arrow, but it's going to go down to the x-axis. So the triangle is always touching that x-axis. It uses the compass arrow, but then that's it. So is the 38 degrees actually in the triangle? And the answer is no. The 38 degrees is not in the triangle. So what is actually in the triangle? And then where does that 38 go? Let me move my 38 down a little bit. I'm going to put my 38, I'm going to zoom way in, and my 38 is going, oops, right in here. That's where the 38 is. Like you got to put it as close to the origin as you can go. That's where that 38 is. Well, we should know what goes under the 38 then. Okay, according to the way triangles work, what's right below the 38 should be 52. Because 38 and 52 do what when they're combined together? Make 90 degrees. So it's actually the 52 that's in the triangle and not the 38. All right, so that's the first part of knowing what to do. The bearing is on the outside. The 52 is on the inside. It all has to do with 90 degrees. 90 degrees is what they do together. Okay, we're going to try another one. Okay. This time, this is letter B, or example B. This time the bearing is going to be 110. Turn that into a reference triangle. Well, I need to know where 110 is. So if we switch back to our compass here, when you draw that, you're going to put it in that quadrant, but you don't write 110. You write 90 and 20. So I'm going to zoom way in. 90 and 20 together. So don't ever write the number 110 if it's more than 90 degrees. always just do 90 and then the extra. Okay, we're going to turn that into a reference triangle. And remember, the reference triangle always has the hypotenuse. So here's my hypotenuse. But then it has to touch the x-axis. So here's my reference triangle. And so what's the measurement that's actually in the reference triangle? 20. Okay, 20 is what's in the reference triangle. So because we have 20 in the reference triangle, we're done. If we didn't have a number in the reference triangle, we'd have to figure it out, but we have it. And so that one, reference triangle is done. Let's try another one. So what we're doing right now is just practicing drawing reference triangles for different bearings. Okay, so now let's do a bearing of 217. All right, well, let's take a look back at our compass. There. So that was about right here or so. Now don't write 217 on the picture. Do it in chunks of 90. So it's 90 here, and then another 90, and then 37 more. So all of that totals 217, but it's really so much better if you break it up into 90 and then 90 and then 37. Then draw your reference triangle. The reference triangle will use the hypotenuse, but then it has to touch the x-axis, so it's going to look like this. And then you realize that there's no numbers inside the triangle because the 37 wasn't actually in the triangle. And so then your job is to fill something into the rest of the triangle beyond the 37. So what would be the space past that? And you're like, oh, okay, well then that's 53 because that has to make 90. Okay, that's where you get that's always in chunks of 90. Everything needs to make 90 when you're working that. So now you have your reference triangle with 53 on the inside. All right, I want to do one more of this kind. So this is option D. So this theta is going to be 303. Okay, 303 degrees. So one more time, I'm going to go back and look at my compass now. Okay. So 303, about right here, and when you label it, don't do 303, do the chunks of 90 that you have. So it's going to be 90, and another 90, and another 90. That gets me to 270, and then 303 is 33 more. Okay, so then you double check 90, 90, 90, 33, that should add up to 303, and it does. And then you draw your reference triangle and you use the hypotenuse. And then the reference triangle has to touch the x-axis. And the 33 is inside the triangle, which is great. So basically, to summarize, we did one in every quadrant. When we were in quadrant 1, we had to make it equal 90 degrees. When we were in quadrant 2, we had more than 90 degrees. It was 90 plus 20, so we had some extra. When we were in quadrant 3, we had to make it be 90 degrees again. And when we were in quadrant 4, we had some extra, which was 33, which was great. So depending on the different quadrants, you may have enough, or you may have a little extra. So now we're going to do some actual problems all the way through. Okay, so we're going to fly a drone at a certain heading, and we're going to figure out how far it flew. All right, so here we go. A drone has heading 121 degrees, and it flies for 15 minutes at 12 miles per hour. All right, we got to turn that into a triangle that we can draw. how far did it fly? All right, so we got to know where 121 is. And so what we're going to do is we're going to figure out 121. Well, we did 120. Oh, no, we did 110 last time. Now we're going to do 121. 121 is more than 90 degrees. How much more than 90 degrees is it? How much beyond 90 degrees do I go? 31. Okay, so when I do this, when I draw it on my picture, I'm going to do 90, and then I'm going to do a little more than that, and I'm going to do how much more exactly? It's 31 exactly. That's how you draw 121. It puts you in quadrant 2. You've got 90 and 31 going that way. All right, so now we want to make our reference triangle. So it's going to come down that way and then going up to the x-axis and going across. Now we know a little bit more information. We know that it was flying for 15 minutes and its speed was 12 miles an hour. So how far did it fly? If it had gone for a whole hour, how far would it have flown? 12 miles. That's what 12 miles an hour means, but it didn't go for a whole hour. It only went for 15 minutes. So how much of an hour is that? Not 1/5, that 1/4. Okay, 1/4. So how far did it fly?
3 miles.
It flew 3 miles. Okay, that's 1/4. Oops, don't like that thickness. Okay, that's 1/4 times 12, because 15 minutes is the same as 1/4 of an hour, which is 3 miles. And so back on my reference triangle now, I know that the hypotenuse is 3 miles. But I also need to know what the legs of the reference triangle are. This is the east leg, because it's pointing east. And this is the south leg, because it's pointing south. And so I want to find east and south also, and I'm going to use SOHCAHTOA to do it. So to find the east leg, I'm going to use cosine, because east is adjacent. To find the south leg, I'm going to use sine, because sine is the opposite side. So let's do the sine of 31 degrees is equal to s over 3. We cross multiply. S is equal to 3 times the sine of 31 degrees, which will tell me my south miles. So my south miles are 3 times sine of 31. That's 1.545 miles south. My east is adjacent, so I want to use cosine for east. So I'll have the cosine of 31 degrees is my adjacent side over 3. Cross multiply for that. So E is 3 cosine 31. And 3 cos 31 works out to be 2.572 miles, and that's in the east direction. So you got to find all the sides of the triangle, not just the side of 3 for the hypotenuse, but the other 2 sides as well. All right, we're going to try and get one more in before the, because we're on assembly schedule. All right, a plane heads at 261 degrees for 3.5 hours at 425 miles per hour. How far did it go? In all the directions. Not just the hypotenuse, but all the sides. So 261, that's going to be in quadrant 3. 261 going to be about right there. That's going to be about 261. When you label, you don't use the number 261, you use the 90s. So I'm going to have 90 here and 90 here. And then to get to 261, I'm going to have 81 more degrees. That's going to be all the way around. That's the total of 261 added up together. Then I create my reference triangle, and I realize that that there's no degrees in my reference triangle, so I need to put something in there. So I'm going to zoom way in. What would go in that little squeaky corner right there of that 81? How much? 9. Right, because that's what's beyond, the 81 degrees. Remember, everything has to do with 90s, and so I can fit 9 degrees. It's really small, but I can fit 9 in there. I also know that I've been going for 3.5 hours at 425 miles per hour. That's just an easy multiplication. That's 3.5 times 425. It just multiplies perfectly together. So you end up with 1,487.5 miles. So on my triangle now, I've got 1,487.5. The other two sides, this is now a west side because it's on the other side of the compass, and a south side. So you're going to set up a SOHCAHTOA to find both west and south using that tiny little 9-degree angle that you're going to have there. So we'll use sine of 9 degrees, and the opposite is s, and the hypotenuse is that 1,487.5, and you'll cross multiply. So south would be 1,487.5 times the sine of 9 degrees, which works out to be 232.696 miles, and that's south. The west would be cosine, and so cosine of 9 degrees is west over 1,487.5, and we cross multiply that. So 1,487.5 cosine 9, and that is 1,469.186 miles west. All right, any questions on that? Yeah. Yeah. How far? Like all the way out to the, like to that?
Yeah.
Okay.
Oh wait, no. A little.
So you can read the question. Yeah. It should be, how far did it go in all directions? Macy, I didn't finish the question. How far did it go in all the directions, right? Not just the hypotenuse direction, but in the sides too.
Thank you.
Yep. Hey. What does that say?
That's, I think that's 7356. I got it.
7356.
Yeah, because it said in the problem, it looks like one is 7256. The other one is also.
That's good.
Thank you.
All right.
Comfortable.
There you go.
Some students like,
Yeah,
yeah, whatever I
that was
want,
good.
that was good. Other people like, I just want to be comfortable.
So you've got
That's my
7,
Oh, come on.
and then you had
That's the overhang. Well, it's the overhang.
The
Basketball, you don't
19.
have something hanging over the rim like that.
right, 19 out here
Yeah.
and 19 down here.
Hidden senior items, yeah.
And so then you need the other side, right? So what do we call this one?
Hidden senior items.
Okay. All right. So yeah, B is adjacent to 19 degrees. Uh-huh. So we
This is 3. That's 3. This is 1 degree. So this is.
I just want to see if the thing works. Like the weed loss.
How far is it? Fire.
So,
Or how far is it? I totally forgot. Find beaches.
I don't want to see it.
You know, like the rest of the one, I think it's easier. So it would better than You're wearing half? Yeah. What'd you do, forget? Forgot, and then you went. So I had things to do that 6 periods on working my hands, and I forgot. I don't know. Maybe when I'll get it back, I'll actually go through it.
Oh, so how do you
So, like, I kind of understood it. It's just I had so many problems.
Sit on Mario. Yeah, that's all I know.
For you from Brennan.
Mean box is not straight, but.
Oh my
Wow.
goodness. Does he do that for everything, or is it? What's that?
Yeah.
For today? Yeah, for today.
Pleasure comes from sleep. What?
What is that?
Later.
Okay, so I think this is it. No Tom, no Brennan, no eating.
Yes.
Oh,
Okay.
wow.
All right.
I don't know.
Eating's in New Mexico
Oh, okay.
with her host family.
Who's her host family?
Rachel Piper's family.
Oh,
Where I
right.
did last year.
Oh yeah, she's still home. What? Rachel Piper, like, and she's at home. Yeah,
Oh, yeah.
Yeah, but she didn't go.
Did we laugh?
They own property out in New Mexico and kind of very remote, like desert, and he decided to go. It's like, why didn't you decide to go over like Martin Luther King weekend or something? I don't know. So, all right, let me save this a minute. Or not.